Hello everybody! Today we are going to cover special segments in a circle. What do you mean? Today you will find measures of segments that intersect in the interior or exterior of a circle. So, let's start off with this. Segments intersecting inside a circle. So we're going to divide this up in three sections. Segments intersecting inside a circle, segments intersecting outside a circle, and then what happens if you got one that's tangent. Okay, so the first thing we're going to do is we're going to talk about chord segments. When two chords intersect inside a circle, each chord is divided into two segments called chord segments. Whoa! And here's the theorem. If the two chords intersect in a circle, then the products of the lengths of the chord segments are equal. In other words, what they're trying to say is that if you take the two sections created by the circles, or the four segments, the two along one line, the two numbers that you would have there, multiply to equal the two numbers on the other line. For example, okay, so here's two examples here. First one says, okay, I'm going to multiply. So I'm going to multiply along here, 5 times 12, because I'm saying AB times BC is going to be equal to EB times BD. So in this case, I'm going to say 5 times 12 is equal to x times 10. 5 times 12 is 60, x times 10 is 10x, and then I can divide by 10 to solve for x. Easy peasy, nothing too difficult, right? Example number 2 makes things a little more difficult. Okay, so here I'm going to have x plus 1 times x plus 8, and then x plus 10 times x. Okay, the x plus 1 times x plus 8, and again, that's stuff that you're going to be seeing next year in Algebra 2, and even if you don't take Algebra 2, you're going to see it in MMA. So, let's look at that, alright? What I would recommend there is x times x is x squared, x plus 1 is x, 8 times x is 8x, so that would be 9x, and then you would have 8 times 1 is 8. And then we'd have x squared plus 10x. The x squareds would cancel out. I can move the 10x over. That would give me negative 1x. Move the 8 over, negative 8, and then divide, and I would get positive 8. And there you go. We'll talk about more about these, and maybe we need to have some sections where we do some multiplication, dividing, or something. Let me begin you ready for Algebra 2. Alright, so here's the next section that we want to cover. The next section that we want to cover talks about a secant segment. And a secant segment is going to be a segment on a secant line that has exactly one endpoint on the circle, and then again the rest of it's on the outside. And you have an external secant segment, kind of go from there. The main point is this. You got one line that goes on the outside of the circle, or you got they intersect on the outside of the circle. So we have a secant segments theorem. If two secant segments intersect in the exterior, then what we're going to do is the short segments times the long segment that goes through the circle, like that. They should equal. Okay, for example. Okay, so here I have an example. Now, what I would have to do here is I would have to add 6 plus, okay, so it's JG, JH times JL, JK. So you're supposed to add, get this whole segment, J to G, which is not just x or not just 8, it's x plus 8. And then you're going to multiply that by this one that's on the outside, which is 8. Then you're going to do the same thing over here. 10 plus 6 is 16. So then I would say 16 times the short segment, or the one that's on the outside, which is 6. Then carry out my distributed property, subtract and divide, and you have your answer. And it should be fairly simple. Can I make that more difficult? Yes, I can. Here's another example. Same idea. And we got this x plus 6, so I'd have x plus 6 times 6, which would be 6x plus 36. 12 plus 7 is 19, and then 19 times 7 is 133. You subtract, then you divide, and you would have your answer. Okay. Then, and that's it. So how can I make that more difficult? Well, it is possible that you can end up with an x squared, but I'm going to show you an easy way how you can type this into the calculator and be able to solve, and maybe sell you a little bit more on those inspires. Alright, so my last thing I want to go over is what happens about a tangent segment. What happens if one of the segments is tangent? You can't divide it up into two sections, so what do? You square the tangent. So, and then multiply it times the length and the short one. For example, here I would say 8 squared. Okay, and then I would say, okay, over here I'd have to add x plus 7. So notice how you take the part that's on the outside and inside and add them up and multiply it times x. So I'd have 64, 8 squared is 64, times x plus 7 times x. That would give me 64 is equal to x squared plus 7x. And now, this is a quadratic formula. There's no way to get rid of the x squared like we have been able to in other problems. Oh no, I didn't remember this from Algebra 1. Here's the thing. I'm going to show you something simple. Your Algebra 2 teacher will probably be mad at me. And if I end up teaching Algebra 2 next year, y'all are going to, I'm going to be mad at myself. Anyways, move the 64 to the other side and have 0 equals x squared plus 7x minus 64. There is a polynomial solver in the calculator that will allow you to type in this equation and say solve it, and it'll find your roots. In geometry, all we want is the positive answer. So in this case, we just want the 5.22, but you would use the calculator for that, and I will show you how to do that. And that is it for today. Simple sections, some little things you got to remember, but we're getting to a point now where we're getting closer to the end, so we better start working on that formula sheet. Maybe I'll start having it up and ready. Thank you so much for your time. Y'all take care and have a good day.